In the last video, we discussed how you can use component definitions to define custom metrics, and we discussed the difference between a metric component and an instance component. And that whole conversation was framed around modifying the systems manager. But really, some of this bleeds over into the server and the device, because those are the places where the metrics are actually calculated. So this is a good time to transition into the server and talk about the scope of the SDK within the server. If you remember, part of a device definition is that it declares support for the metrics that it can calculate. So if a channel is configured for a device and that device declares support for that feature, then the server will yield calculations to that device. But if a user configures a channel for a metric and the device does not declare support, then it is up to the server to calculate that metric. So let's review the role that the server plays within the InsightCM framework. Now the server is a single system that is talking to presumably many devices. The server's job is to aggregate data from all the data acquisition devices, facilitate communication to the devices, and manage all of their configuration and images. The server can also perform analysis on incoming data files, and this is what we called earlier as in-motion analysis. The server is also capable of evaluating alarms, and it also pushes data to Pi and OPC UA. Now the SDK allows us to open up the in-motion analysis part and put custom analysis inside of it. And the SDK also allows us to extend this idea of integration with other applications. So again, if the device does not support a configured metric, then it's up to the server to perform that calculation. So I brought up an example of a metric component, and the last piece that I want to talk about is this field called analysis VI. So basically, if it's the server's job to calculate the metric, then the server will look for a VI at this path to run the algorithm. Why would a channel be allowed to have a metric that its device does not support? That is because one of the use cases of the SDK was to give the server the ability to add analysis without having to modify device code. I mean, perhaps you don't have access or the means to alter device code, or you may want to recalculate metrics with a different algorithm that the device used. This enables us to run analysis on the server without having to modify anything on the device or the definitions of the device. So this is a snippet from the data flow diagram that we discussed earlier. I've zoomed in here on the file services and the in-motion analysis portion. So if you recall, the devices can send files periodically to the server, and every time a file arrives, it kicks off this in-motion analysis VI. And this is the part that the SDK opens up. So basically, all you need to do is have a VI that adheres to a certain connector pane and whose path is declared in the metric component, and we can run whatever analysis we want here on the server. Now, one key here is that when this VI is deployed, it must be built in such a way that it doesn't make any calls into VI lib, because most servers won't have LabVIEW installed. So it needs to be built into a source distribution or a library that includes VIs from VI lib. And this is another place where the SDK help will go into more detail. So we're going to open up the VI and look at it more closely here in a minute. But I just want to re-emphasize the difference between tags and features inside of InsightCM and make the point that inside of this VI, after the algorithm has been run, you can publish the results of that algorithm as a tag so that it can be pushed to a historian or so that it can show up in the device dashboard. And the results can also be written back into the file as a feature so that that data can be viewed in Data Explorer. So the SDK comes with an example metric called mean, and let's look at it now. At C, Program Files, National Instruments, LabVIEW, Examples, InsightCM, Analysis Mean, there is this example project here that includes both a VI and its definition. So let's open up this definition in Notepad++. And a lot of stuff here should look familiar. This is the metric component. So we have the name of it here. Pretty much everything else is blank in it for now. And if you notice, this is a field called can create instance, and it is set to false. This means that in the web, users cannot create additional instances of mean. And then we have this field analysis VI. When we configure a channel to run this metric, this server will look in this directory to find the algorithm. So in a future video series, I will walk through the entire process of how to upload, configure, and run this custom analysis on the server. But for now, I just want to make you aware of this example and to briefly look at its block diagram. So I'm going to switch over to LabVIEW here. This is the project that was in that directory, and we're going to open up the mean example. Notice it has this connector pane that all in-motion analysis VIs must adhere to. And we'll switch to the block diagram here, and you'll see that there are 3 inputs to this template. There is the device model. This is the entire configuration of the device that created this file. There is the plugin info. So this is basically the information of the metric that is being run by the server. And then we have a reference to the TDMS file. So what's happening in this VI is 3 things. The first thing that we do is we calculate the metric. And if we open this up, you'll see that it's just a basic calculate a mean. Then the results of this average, the results of this mean, is going to 2 places. It is being written back into the file as a feature, again, so that Data Explorer can trend off of this value. And it is also being written as a tag back to the server. This VI basically formats that tag, and any tags that are in this message indicator will get published to the server. Once the tag has been published, it can be used to create custom alarms. It will show up in the device dashboard and can be exported to a historian.